All right, we're going to do number 39 from chapter 6. In this case, we have a beam, a 1,000 kilogram beam, or what we would say 1 metric ton, hanging by 2 ropes. One that's 20 degrees off from vertical, one that's 30 degrees off from vertical. And we want to find the tensions in each of those ropes. Okay? So we're going to solve this. This is a good example for how you solve a problem. We're going to do these steps. So the first thing we're going to do is a free body diagram on the beam. Well, you always have gravity. In this case, it's just mg. Then we have tension. And I'm going to draw my axes here so we can keep track. So this is tension 1, and this is 20 degrees. And then we got tension 2 coming off here at 30 degrees. All right, those are the only forces acting on it. So there I did step 1, that's the free body diagram. Now both tension 1 and tension 2 are not on either axis. And so I need to get their components. So I'm going to have one component of T2. This is T2 cosine 30 degrees in the y direction. And over here I'm going to have T2 sine of 30 degrees in the x direction. Same thing here for T1. If I drop this down here, this is going to be T1 sine of 20 degrees in the x direction. And this here is going to be T1 cosine 20 degrees in the y direction. All right, so now I've taken the components. Now I have to put F net, and I have to set it equal to 0 or to ma. Well, this beam is not accelerating, it's just stationary, okay, or what we say it's static. So then both the net x and net y are going to be equal to 0. So I'm going to do these separately. So I'm going to do F net x, and I just sum up all the force in the x direction, which I do off my free body diagram. I have positive T2 sine of 30 minus T1 sine of 20. Notice that goes to 0 because it's not moving. And then I can move this to the other side. I can say, oh, well, T1 sine of 20 is equal to T2 sine of 30. However, I can't solve it because I don't know T1 and I don't know T2, so I have 2 unknowns. So I'm going to have to do F net y. So let's do F net y. In the y directions I have, right here, both these are positive. So I have T1 cosine of 20 degrees plus T2 cosine of 30 degrees minus mg. Again, this is equal to 0. Okay? I'm going to move the mg to this side and say mg is equal to T1 cosine 20 plus T2 cosine 30. Now again, I can't solve it because I don't know T1 and T2. But I now have 2 equations, 2 unknowns. I can solve that. The easiest way up here is I'm going to solve this for one of them. I can do either one and then plug it into here or substitute. So I'm going to solve this up here for T1. So then T1 is equal to T2 sine of 30 divided by the sine of 20. And then I'm going to plug that into here. So this will become mg is equal to T2 sine of 30 over the sine of 20 all times the cosine of 20 plus T2 cosine of 30. Now what I did was I just eliminated T1, so I only have one variable now, and I can solve that for T2. So I'm going to factor out T2 from that side. I'm going to say mg is equal to T2 times sine of 30 cosine of 20 over the sine of 20 plus the cosine of 30. Remember, those are all just numbers. And then to solve it for T2, I'm just going to divide by that. So I'm going to say, oh, T2, divide both sides by this big amount. So T2 is going to be equal to mg over sine of 30 cosine 20 over the sine of 20 plus the cosine of 30. And we can plug in the numbers and we say, oh, well, this is just 1,000 times 9.8, all divided by sine 30 cosine 20 over the sine of 20 plus the cosine of 30. And when you do that, you get the tension for T2 is equal to 4,380 newtons. And then for T1, I already have the equation for T1 in terms of T2, so I'm just going to plug that back in here and say, oh, well then T1 is just equal to 4,380 times the sine of 30 over the sine of 20. And we get T1 is equal to 6,400 newtons. Okay. That's how you do it. And you want to do every problem the same way. These 3 steps. And then it's usually a bunch of algebra.